So just going to double check our size. So the sample is varies between 36.35 and 36.4. So we're 36.39. .3839. Okay, so that's just a thread wire dropped in the groove, and then the anvil of the micrometer just picks up on the top of the spline 180 degrees away. So it's just it's not a specifically sized thread wire. It's just one I've picked that sits 2/3 up the or between half to 2/3 up the side of the spline. You don't want one sitting right down the root. You don't want one sitting right up the top. So I think now we're safe. We can we'll pull our tailstock out the way, and that was the idea of these two hard stops. So we can pull our tailstock clear, and if for any reason, say on this one, we have to put the tailstock back because we have to do another thou or so off the spline, we know we're going to be back in the right location here. And same goes when we do the other end of the spline. We turn our shaft around and our tailstock will come back into the same location. So what I don't want to mess with is, I would really like to avoid messing with the depth that the machine is set at. So the cutter is still buried in the spline at depth. As I said, it had to be that way. Otherwise I couldn't shut the workshop door, which is, it's not a good practice to do, but it was unavoidable in this case. So yeah, let's get this tailstock out the way. And as for a double check too, more of a sanity check, just use the gear tooth vernier as well, and just a comparison between our spline and the sample spline. I'm going to get a spanner that fits these nuts. There he goes. So on our sample, the spline is a tap-on fit, and on this sample spline, one end of the spline that's cut in here is a smidgen bigger than the other. Okay, let me just get my copper hammer. Might need a little bit of deburring. I might need a spring cut. Or I might need to take another half a thou off it. Okay, I don't know how focused this is going to come out. So we have one spline here, this one right here. Now this is the first spline that I cut, and you see it's just picking up a little burr just there when we tried to fit our test bush on it. So I've just mic'd across that one with the thread wire, and that one there for some reason has not quite cut to full depth. I must have still been adjusting the cut and possibly missed it. So I'm going to put the tailstock back in, and I'm just going to, because we're still at depth, we haven't changed anything, I'm going to run the cutter down that single spline there, and that should bring us to a good fit. Also on that slightly undercut spline, you can see our witness marks from the cutter there and every other tooth, except for that one there. So turning the end down to the ID, the root of the spline, it's become quite helpful in seeing what's going on as well. Right, we'll wind this back. Just make sure that our cutter does not have a tooth in contact, so we're in between two teeth, so I can move the cutter by hand. So we did not have a tooth engaged at the time when we shut the machine off. So I'll wind this back to the start. And then we can index around. But I better open the roller door before I can wind our shaft back, otherwise it'll hit the door. Because if you don't, the end of the shaft hits the fucking door. Okay, we'll try that again. If that's the worst thing that's going to go wrong all day, we're going to have a good day. Okay. One more spline. Make sure our plate's locked off. Okay, it looks like we're correctly indexed, so we'll just gingerly come in and just see what happens at the start there. A few comments in the other video about these funky spaces. I don't know, they never seem to be able to make them right, you know, do they? I think the only way you're going to get spaces that run true is if you make your own ones. I think they really messed up on the chamfers of them, and that's what's making it look like they're right out of whack. I'll put them in the lathe and we'll just recut the chamfers on them so they don't look so bad. Okay, let's just sneak this in. And I can just hear the cutter now, yeah, touching the root diameter. It's looking quite good. I'll just see if I can sneak in a measurement there. I don't know if we've got enough length there to get our wire down. No, we haven't. What I can do is okay, I think we're going to be right. Let's send it. Right, we'll have another test fit. Just turn our oil off. So we'll just get another measurement of that one just to verify. And that's spot on where it needs to be. I'm very tempted to run around and do that spring pass on them all. I think I'm going to do that, but before I do that, let's just remove the tailstock and have a test fit, because this has to be a really neat fitting spline. There's no room for error. Not only has it got to be a neat fitting spline, it's also got to be indexed to the one on the other end as well. Oh, that's fitting good. I'm going to do a spring cut. Okay, this is going to be a big call. I'm going to do a spring cut. It's one of those situations, you're damned if you do and you're damned if you don't. Reason, this spline, I'm pretty sure it's a genuine spline, according to what it looks like on the box. But inside, it's not. If you compared this spline here, the finish, say to a Caterpillar one, it's like comparing chalk and cheese. So Caterpillar ones are pretty well perfect, and this I can see tool marks and a bit of other malarkey inside. So I'm going to do a spring cut. I just don't want, when this gets assembled up, for this to pick up on one of the splines on here, and hopefully they'll put anti-seize on it when they assemble it. So I'll do the spring cut. I'll start it and then I'll turn the camera off, because it's just a very light, well, hopefully it won't take anything off all the way around. It'll take a few microns off. It's the amount we're playing with, we're under half a thou. So I'll just mark this one here. That's our start. Right, that's a spring cut done all of the way around, so we will repeat the process and have a test fit. And that's exactly what we want. It does not get any better than that. You see the difference in the coupling from one end to the other, and that fits exactly the same on our sample shaft. So, all right. Yeah, it gets a bit nerve-wracking on you for a close fitting spline like that. You know, you've got a lot of hours invested in already, so you don't want to be overcutting the things. So what we'll do, we won't touch any settings, and we'll take the shaft out, we'll do the machining, we'll do the turning on the other end, and when we put it back in the mill, we should be cutting bang on size. So let me get this one out and we'll meet you over at the lathe. Oh, before I do that, they're set up because these splines have to be indexed to each other too. So let me show you how I'm going to do that. Okay, this is one of those cases where you need to have your machine level, because if it's not level, the procedure that we're going to do, you're going to have any error will be doubled. So double check your machine is level. Then I'm going to use this 4-jaw chuck, and we're going to take advantage of these 2 flat surfaces that we have here. So we'll set up a couple of blocks and we'll run our level between these 2 jaws. So with a bit of jiggering around, our level will sit on the jaw, so we can get it close as we can to the center, and then likewise the other side, and we're looking pretty good. So that's just a simple, very accurate method of clocking a shaft, especially a long shaft like this. And you just got to be mindful, use your tape measure and put it in a spot where further operations, this isn't going to be in the way. For example, when I turn the shaft around here, it's not going to hit our steady rest. When the shaft goes back into the lathe, it's going to clear everything, you know, things like that. So just a bit of forethought involved in it, but that will do the job. And lastly, we put a marker on. referencing where our cutter has to go. So it's no good, because we're cutting 21 splines, it's no good us re-leveling it when we turn the thing around on the opposing jaws, because as soon as we release it from the machine, we're going to lose this reference. So put here, our cutter must be cutting right there, and then we'll be timed. So I don't know, I know for sure on one end of the shaft is a universal joint, and I don't know about the other end. I know there's that coupling, but I don't know if that couples onto another universal joint. And if your splines aren't lined up, your universal joints will be out of phase and they'll chop out. So. Right, it should be safe for us to take this out the machine. This is the time, and it's the only opportunity he'll get. Just take 5 minutes, have a breather, double check, make sure you've got every base covered, because once we release this from the chuck, that's it, we're committed. So what I'll do this off camera. That way I can turn the radio on, let's do a bit of music. I'll get this out, I'll get it marked, I'll get it cut to length, and we'll meet you over at the lathe when we're setting this up back in the lathe. Okay, so we've got our shoulder to shoulder length, and I've dot marked our one, which will represent the shoulder. So off to the lathe. We just re-clocked the bar in. I clocked it up at the 4-jaw already, run true. So we're within 1/100 of a millimetre here, which is fine. And we'll go back to the chuck, and that will probably have to be re-clocked in again, as this long slender bars, they like to move. So prior to adjusting the rear spider, I had this clocked in within 1/100 of a millimetre. So we're 4/100 of a millimetre out, so we'll readjust the chuck. Just going all over the shop. Just slacken this off in case we've got any flex in the bar influencing what we're reading. Re-nip it. Just flopping around. I'm going to swap this indicator out. It's pissing me off too much. It's moving around too much. I'll be back. Right, we'll see how this one behaves. It's my old Mercer half-hour graduated indicator. And I haven't done anything, and we're running 1/4 hour. So that my Mitutoyo, the metric one. That was just all over the shop then in that previous shop. Now we're quarter of a thou. So I'll just make sure we're tight and then we'll let that go. Okay, so just on a quick note, this is 1.5" shafting. Yeah, it is pre-hard 4140, but when you get a long piece like this, it's like a piece of rubber. So that's why we initially indicated it in here, then we went and done the spider, then we came back to here and we released the jaws to take any influence out of it. We'll release 2 of the jaws and reclamp the jaws, and we're in a good position now. It's a bit of a process. It's not just put it in and indicate it straight in. You got it. There's a bit of toing and throwing from one end of the shaft to the other, to the middle. It's a bit of mucking around to get it right, but now it's right. So this end here, our steady rest is still preset on diameter from before. So it's just a matter of I might just slide it down towards the headstock a bit as we have to machine off back to about here. So the electrics fucked up in the big lathe. So something's going on down here. I had to replace the stop button the other day. So we've got other issues as well. So, as they say, any port in a storm. There's our shaft there. Had to finish it off in the little lathe. But we got it done and it's ready now for the milling machine. Who says you can't have a bit of overhang? That's a couple of metres of overhang there. Alright, let's head to the milling machine. Yeah, so there were a few very colourful expletives involved, so that's why I did not film it. So we're back in the mill. I've just done 3 cuts. Just going to check, get a size check. Ah, 36.39. So we're aiming. We'll probably have to do a spring cut at the end. That 36.37. As long as we're between 36.35 and 36.38, we're in position. We're 36.9. I'm not going to touch any settings. And we might just run a spring pass through, the same as what we did when we did the other end. So we'll get it fired up and we'll keep it carrying on. So as you can see, it's like watching bloody paint dry. So we'll bring you back when we've completed all of the splines and we're ready for the same test fit. Hey, while I'm here, anyone want a drill press? Going cheap. It's a Herbert. Got some good speeds on it. 2850 down to 74. It's one of these old production shop ones with the turret head on it. If it stays here any longer, like it just rocked up today, I don't want it, but if it hangs around here too long, it will end up outside as my letterbox. So anyone wants to buy a drill press? The problem, like with these sorts of drills though, is you got bugger all throat distance in here, you know. Decent sized table, but the drill spindle comes down where that hole is, you know. So, old classic bit of machinery. Got some wild looking electrics in it. And good neck too, original. Might nick them and put them in my horizontal borer, put the old ones out of my borer in this thing. No one will ever know. Alright, I better get back to me job at hand and get another another spline happening. We've just indexed around for the last cut, so I'll let this one run through. Measurements, like, we were pretty good for size. We're possibly, it's looking like we're 0.02, 7/10, whatever, up on size. So yeah, like the other one, it will require a spring cut. But before we do a spring cut, we will pull a tailstock out the way and have a test, just to be sure. So, hey, just to keep me going, the wife brought me in something to nibble on. Food fit for kings. Sausage, cheese and gherkins. Beautiful. Alright, I'll set this cut going. Turn the lights on and see a bit. I was totally oblivious to the fact that I had the lights off down this end of the workshop. Turn this oil off. Don't need that anymore. So I am anticipating we will need a spring cut. Yeah, I think we're about 0.02 millimeters tall, bit over 3/4 of a thou. Yeah. Spring cut. So you can see now the advantage of setting this hard stop here for our tailstock. That went in. No. So we'll just mark our starting point. Rip round. With the spring cut, I'll bring the RPM up a little bit higher, probably 140 RPM, and I'll increase the feed up to probably 63 millimeters a minute, which is right there. So we were on 100, so we'll bring it up to 140. So that one's down, and this one is over there. And our feed, we'll just bring it up to 63 millimeters a minute. So I'll just rip round these off camera, and we'll bring you back for the next fit up. Alright, that's our spring cut done, so let's slip this tailstock back out the way and have a test fit. Hopefully she'll go this time. That's looking good. Yeah, we'll let that go at that. Right, so what's left now, we have to cut them to length, and one end is a slight scallop feature to machine in. That's just for a pinch bolt. We can get rid of this now, not required. Don't need our steady rest now. Oh, this steady rest was a dumpster find the other week. Come in handy just in the nick of time too. And we can release our chuck here. Right, we'll get these in the saw now and get them cut to length. The reason they have to be cut to length is I gave myself a bit of foobar protection. So if anything messed up down here, this was excess. So the same goes for the other end. That's cheap insurance. All that means is now I've got to pop it back in the lathe and do that groove, face them off, which is nothing. Okay, we're set back up in our small lathe. All I have to do is face the end off and put a scallop for retaining a pinch bolt in this end here, and the other end's just got to be faced off. So we've got 2.4 meters hanging out the back, secured in our steady rest. So I'll just give you a quick tip when if you're stuck in a position like this. What I do, because I don't have yet a spider or cat's head as the Americans call them, I get a feeler blade and I slip it in 4 positions around the shaft. Make sure it's even, and that's the guide to tell me where to set this steady rest to. And it takes all the loading off the chuck jaws. The chuck's just holding the weight of this end and rotating it. It's not pulling or in any funky angle. So I can run this, what are we on, high 3, slow pulley 3, 420 RPM. And everything's looking tickety-boo down there, everything's happy. Yeah, so I'll get this faced off camera and bring you back for the end. And of course the JFMT lathe behind us there is a very high priority job, and I'll be hammering away on that ASAP just to take, so we don't have another occasion like this again with the old heron down till I sort out the electrics. Right, we're finally at the end of it. You can see the old one, just a little bit of wear on it. It has a bearing that slides. It's a neat slip fit. It has 2 bearings on it actually. And the other end's all complete. We had to machine in the scallop for a retainer bolt. So I think it's off a New Holland bit of farming equipment. So yeah, well, we'll bring this one to a close here. Job came out very well. All of our setup tooling worked perfect. Still not overly impressed with the smallness of the indexing plate. Yeah, I should have got a bigger one, which I probably still will do in the future. Milling machine went great. It still does need its final give adjustments, but as soon as I get a window of opportunity, I'm going to be pulling off the table, the saddle and the knee. So I want to go through the oiling system and make sure the gibs are all in good condition and correctly adjusted. So that is a major job. For this, there's no, as far as the innards go, I'm not going to touch them. Everything's working well, so we'll just leave that side well alone. Just the big lumps off, and yeah, sort the oiling system. Well, I think it's working, but I just want to be sure it's working 100%, and yeah, do all our gib adjustments, and she should be a good machine, this one. Well, once we're rebearing the vertical head as well. So anyway, cheers, thanks for watching, and I'll just point out cutting splines in a milling machine, as far as I'm concerned, it would have to be up there, like fine tolerance splines. It's got to be up there with the more difficult jobs you could do on a milling machine. Like cutting gears is easy compared to cutting splines. Although gears, yeah, you've got to be on size, but if you're a little bit out, it's not quite the same effect as being a little bit out on a spline. So just something to be aware of if you're doing or planning on cutting any splines. So, and plus the identification of them too is just an absolute nightmare. Anyway, that's enough babble. Cheers, thanks for watching, and hopefully see you in the next video, where I have to go and reset up the job I'm in the middle of that we're doing over in the Bridgeport. So, cheers.